You've probably heard the term EVM everywhere now. In fact, way more projects use it other than just Ethereum, even though it was built for Ethereum. Avalanche, Polygon, Binance Smart Chain, Phantom, and tons of other chains use this highly specialized blockchain technology. So what does it mean? What does it do? And how does it work? Welcome to Whiteboard Crypto, the #1 YouTube channel for crypto education. Here, we explain topics of the cryptocurrency world using analogies, stories, and examples so that anyone can easily understand them. In this video, we're going to be explaining what the EVM is, how it works, and why so many blockchains are utilizing it. Before we get too far into what an EVM is, if you're interested in learning how to be a Web3 developer by going through my very own bootcamp, that'll teach you how to build any dApp imaginable, you should go ahead and click the link in the description to join the waitlist and get notified when it launches really soon. Moving forward, what is the EVM? Well, I'm just going to jump right into it and say the EVM is an acronym for the Ethereum Virtual Machine. To completely understand this, we have to understand what a virtual machine is. Technically, the EVM is a cloud computer that is operated by all the nodes that contribute to it. This means that it's not a single computer somewhere. It's the accumulation of thousands of computers around the world. In reality, these computers are made up and operated by people like you and me. Each computer on the Ethereum network runs a piece of software that is basically just computing the output of smart contract transactions. Now, this theoretical cloud computer, EVM, has many similar parts to a real computer, such as memory, storage, and a part specialized for computing numbers. It is different though from a real computer because it doesn't need a monitor or a keyboard or a mouse, but it does need a few unique pieces like a part to be able to understand and read smart contract code. The EVM though is basically just a computer specialized at processing smart contract transactions. Now moving forward, smart contract code written by developers is what the EVM processes. Truthfully, there are a few different EVM languages that developers write in. However, the most common one is Solidity. Solidity is a programming language that allows developers to write code that they can understand and make predictions on how the code will work. In reality, code can work in ways that we don't expect it to. Solidity is not the code that the EVM reads and processes though. The EVM reads something called bytecode, which is basically just a bunch of ones and zeros. You probably already knew that computers do math in binary or ones and zeros though. When a developer writes a smart contract, they must compile it. This is a term meaning they turn the Solidity language code, which is human readable and understandable, into bytecode so that the EVM can understand it and read it. And this is mostly because humans aren't really good at reading a bunch of ones and zeros. So we came up with Solidity for us to be able to read and write code much more effectively. Essentially, this compiling process is just a way to translate human code to machine code. As I mentioned earlier, this translation process does leave us open to vulnerabilities, but that's for another video. Now, hypothetically, in between Solidity and bytecode, there's a middle theoretical language called opcode. Opcode is quite literally a language that shows operational code, or rather instructions, the instructions that the EVM must take to perform a smart contract transaction. You might recognize or be able to predict what some of these opcodes do, for example, push, mstore, is0, and call. But you should know that there's over 100 different opcodes. I called this a theoretical middle language because most people don't write opcode, and the EVM doesn't read opcodes. Each of these codes, though, does cost a certain amount of money to be run on the EVM, and if you add up all the opcodes in a single smart contract and multiply each opcode by the cost of each opcode, you get the total amount of gas, or money, that it takes to deploy or use a smart contract. The more complex that a smart contract is, the more it costs to use it. And this is because you're making the EVM do more work. So each smart contract can be broken down into a list of operations, which can be named by their opcode names. Also, some opcodes are more expensive than others, and some opcodes are more common than others. One really interesting thing about blockchains that use the EVM is that it's really easy to move your projects and applications from one chain to another if they both use the EVM. This means if you have an application on Polygon, it's very easy to move it over to Phantom or Avalanche or Ethereum. You can move your project around where your customers are most likely to be. Now, this is unlike Cardano or Solana, which use Rust. Developers are highly incentivized to program things using Solidity due to the massive market that they could reach just by migrating their app from one chain to another. The next thing I want to talk about is how the EVM processes transactions. The EVM processes transactions sequentially, one by one. This means it doesn't do a whole bunch of things all at once, and if a process doesn't work for whatever reason, maybe for example, say you're trying to send someone 1 ETH, but you actually only have 3/4 of an ETH in your account, then the transaction is skipped. Each time the EVM runs a transaction, we say that the state of the EVM is updated. Since the EVM is really just a collection of data, of information, each transaction that the EVM processes simply changes that data that is on the EVM. We call this collection of data a state. If one thing changes in the EVM, if just one number changes, then we say that the state of the EVM has changed. Each transaction changes the state of the blockchain, and if you wanted, you could make a copy of the blockchain and roll it back to any state in the past that you wanted to. In short, what this means is that each time the EVM changes or processes a transaction, there's always a complete record of what the EVM consisted of before the transaction and after the transaction, and this list of transactions is what we call the blockchain. So as a review, the EVM is a virtual computer that's a collection of thousands of individual computers all out there running the same smart contract transactions. This virtual computer has rules and can only understand binary code, which consists of ones and zeros. To be able to add transactions to the EVM, developers create secondary languages such as Solidity, which allows humans to write code in the English language so that they can have the EVM perform what they want it to do without needing to understand the binary code. The cost of a smart contract is simply determined by what work the EVM performs, whether it's reading data, writing data, or both, and also how much data it reads or writes. We can actually know specifically how much a smart contract will cost to run by looking into the opcode of a transaction, which is literally the operational code or the instructions of a transaction, where each operation costs a certain amount of money to perform. For instance, adding two numbers might be 1/1000th of a dollar. Add up all of these opcodes and their costs, and you get the total cost to perform a smart contract transaction. Also, when transactions are submitted to be processed by the EVM, they are ran sequentially, one by one, and each transaction changes the state, or the collection of data that the EVM holds. This data could be token balances, or maybe amount of a loan to repay, or even a simple chat message. Overall, the EVM is made out to be a really sophisticated idea, but essentially, it's just a specialized computer that's designed to process DeFi transactions. Finally, as we end this video, if you actually learned something about the EVM in this video, or maybe how it worked, and you found it interesting, you would be a great candidate for my upcoming Web3 bootcamp. I'm only opening the doors for a week next week, and if you want in, you'll have to join the waitlist below. Technically, I've had a very small group of 30 people go through it already, and they loved it. We created tons of different dApps with the goal of being able to create any dApp idea that you can think of, or score a high-paying Solidity job by using these dApps as your portfolio. If you're interested in Web3 at all and want to build something for the next bull run, I highly recommend joining the waitlist below. Thanks for watching, I hope you enjoyed this video, I really hope you learned something, and most of all, I hope to see you in our next video.